Solving rational equations with variables in the denominator, Part 1. Question 6. The following rational equation has denominators that contain variables. For this equation, write the value or values of the variable that make the denominator 0. These are the restrictions on the variable. B. Keeping the restrictions in mind, solve the equation. So first, we're going to complete Part A, and we want to write the values that make the denominator 0. So we'll look at each denominator and set it equal to 0 and solve. Now if you'll see, both denominators are the same. So I really only have to place one denominator, x plus 2, equal to 0, and solve for x. I need to subtract 2 from both sides, and I get x equals a negative 2. So this tells me when there's a negative 2 and for x, my denominator goes to 0. And I can't have a denominator of 0. So negative 2 is called a restriction on the variable. In other words, x cannot equal a negative 2. Now I'll solve Part B. We're going to solve the equation for x. Now I have a denominator of x plus 2 in two of my expressions. So I want to get rid of the denominator in order to solve. In order to do that, I'm going to multiply the entire equation by x plus 2. That means I need to distribute the x plus 2 to each term in the equation. When I do that, I get an x plus 2 times the 3 over x plus 2 plus 4 times x plus 2 equals x plus 2 times 23 over x plus 2. Next, I'll simplify each term. So an x plus 2 times 3 over x plus 2 is just 3 because the denominators cancel. Next, I need to multiply the 4 through each term in the x plus 2, so I'm left with a 4x plus 8. And then the same here, the x plus 2 cancels on the top and the bottom, so I'm left with a 23. Next, I need to combine like terms on the left side, so I have a plus 8 and a positive 3. 8 plus 3 is 11. So this is 11 plus 4x equals 23. Now I'll subtract 11 on both sides to isolate my x variable. And I have 4x equals 23 minus 11, which is 12. Lastly, I'll divide both sides by 4 to get the x by itself, and I get x equals a 3. Now remember, Part A told me that I can't have x equaling a negative 2. Well, since x equals 3 and not a negative 2, I know that this can be a solution to my equation. So my solution set is x equals 3.